3a squared minus 7ab minus 6b squared. It's been a while, so sometimes that extra variable throws you off. This is no different than if I would say 3a squared minus 7a minus 6. You just get that second variable in there. So you're going to do it exactly the same. So this would be 3a times a and 3 and 2. This can't be a 3 here. Minus 3 plus 2. But we got to account for that b. All you have to do is make sure you have that b on that second term. So think about this. 3a times a is 3a squared. 3a times 3b is minus 9ab. 2b times a is plus 2ab. Minus 6b squared. Okay. So if you do have that second variable there, you're really doing exactly the same. So you got to tack on that extra variable for that. Number 9 here on the left. A lot of people it gets thrown off because you're used to n squared minus 36. Well, 36 minus n squared is 6 minus n times 6 plus n. You can do it like that. That's perfectly fine. You can't just flip those around. Okay, you can't. I mean, that's close, and I understand what you're doing, but those aren't the same. 36 minus n squared and n squared minus 36 are not the same. What you could do, if you really wanted to, you don't have to. If you do flip them around, you got to factor out a negative in front. Okay? So technically, you could have a negative and then have n minus 6, n plus 6. But there's really no reason. You can just leave it 6 minus n, 6 plus n. Okay. Also, when you submit, there's a place for comments. If you want to put down, you know, I had trouble with, I don't know, 18 through 20. Like there's something like more than normal. You can put that in, and then I'll be able to, you know, see that and at least have an idea, maybe address it for that. Make sure that last one, you get a squared plus 25. That doesn't factor again. Any other questions? No? Okay, good. Good. All right, we are going to finish up factoring. In your notes here, go ahead and get those out. And just copy that down and then just wait a minute. Where's the textbook form, textbook sheet? Okay. Anybody else need it? Textbook sheet, put it down. We're good. All right, just regular trinomials. Yesterday I did guess and check. How many of you do the grouping method for those, for the most part? Okay. I don't really care which way. If you're doing guess and check, which would be, I would just make this 2x and x, and then, all right, I'm going to say I got to get a negative 6. So I'm going to do plus 3, make it minus 3 plus 2. Does that work? And some of you are like, I hate that way. You know, I can never get it. But, all right, what's the other way? What's that first step that you do if you're going to do, quote, the grouping method? Nathan, did you have your hand up there? No, for the grouping. Who had their hand? Aaron, how do you do it what's the first step?
You multiply the 2 and the negative 6.
Okay, you're going to take 2 times negative 6 is negative 12, and then we look for 2 numbers that add up to, that multiply to get negative 12, add to get the middle number, which is 1. And that's the whole key. You got to find those 2 numbers. Well, what are those 2 numbers? What multiplies to negative 12 and adds to 1? Negative 3 and 4. And now you take those 2 numbers and they basically replace your middle number. So you take the 2x squared and we make it minus 3x plus 4x minus 6. And then we group. You group the first two, group the last two, and I get an x, a common factor there. And I get 2x minus 3 plus a 2 is my common factor there. 2x minus 3. And I get 2x minus 3 times x plus 2. Well, it depends on the problem. A lot of times I can get it a lot quicker this way, but I know a lot of you love the fact that you got the steps to rely on. Okay. I'm not going to require, I'm going to do it 9 times out of 10, just kind of guess and check them when I go through my notes. So you're going to have to be able to follow. All right, second one. What do I multiply together? Okay. And I'm going to go through these. Peyton, Raider, what do I multiply together?
3x and x.
No. What do we, if we're going to do it the grouping method for this one?
Multiply 8 by 3.
Yep. 3 by 8, which is 24. And now I look for two numbers that do what, Peyton?
Add up to 14 and multiply to get 24.
Yep, I need two numbers that multiply to get 24, add to get 14, and 12 and 2, right? So I get 3x squared plus 2x plus 12x plus 8. I hope you know that it doesn't matter which order you put those in, you're still going to get the same answer. You're still going to get the same answer whether you put, hold on here. I'm having issues. The 2 or the 12 first. And what can I pull out of here? I can pull out an x, and I get 3x plus 2 plus 4, 3x plus 2, and then you get 3x plus 2 times x plus 4. Okay, for that. All right, go ahead and do the next two. I don't care which method you use. If you want to do grouping, if you want to do guess and check. See what you come up with. All right, let's, I'm going to do, I at least want to go through the grouping with this one because of the negative in the middle. We'll What are two numbers that multiply to get 18? And that's a P. Multiply to get 18 and add to get negative 11. And it's got to be negative 9 and negative 2. It's got to be two negatives. And so when you're doing this, so 6x squared, I'm going to just put minus 2x minus 9x plus 3. And you get a GCF here of 2x. And you get 3x minus 1. Don't forget 2x divided by 2x gives you 1. And if this is a negative, then your GCF you need to treat as a negative. So you put a minus 3 here. And then you get 3x minus 1 there. So I get 3x minus 1 times 2x minus 3 for that one. And always double check. Make sure they multiply back together. All right, now on the last one, guess and check. My first instinct would be to test 2x and 2x. But when you look a little closer, then you really don't have to go too far before you eliminate that. Why can we eliminate 2x and 2x even though I'm doing guess and check? What are my options for 12? First thing is 1 and 12. Well, that can't work because 12 will have a GCF with one of those. What about 2 and 6? They both have a GCF. They can never use them. And 3 and 4, same thing. So if you do minus 3 plus 4, you can't even test it because you got a GCF. So no matter what option you pick with 2x and 2x, you always run into that roadblock where you got the GCF. So I know now that I'm just going to test 4x and x. My first instinct for 12 is 3 and 4. Doesn't guarantee it, but that's just seems to work out. I cannot put a 4 here. I'll put it there. I need a minus sign there. And so if I do a little bit of mental math, I'll figure out I'll get 4 times 4 is negative 16x. 3 times 1 is 3. They add up to negative 13, and there's your second answer. Again, I don't care if you feel more comfortable doing this, fine. If you just understand better using guess and check, fine as well. Okay. All right, some perfect square trinomials. Okay. These are exactly the same form in terms of it's a trinomial. You could do this by guess and check. You can do this by grouping method. But one thing you should do on anyone is just take a quick peek at the first and the last term. If they're perfect squares, you might be able to get away with saving yourself some time. Perfect squares, remember what those are? Perfect squares. Okay, it's like 1, 4, 9, 16, 25, 36. You know, you square a number and you get the answer, that's the perfect square. Well, is 4 a perfect square? Yep. Is 25 a perfect square? If your first and last number is a perfect square, I would immediately test 2x and 2x here, 5 and 5 here. You just got to fill in your signs, and those both have to be pluses. Doesn't guarantee it'll work, but 95% of the time it does. Does that work? Yeah. So just take a quick peek. All right, is your first and last term perfect squares? Now I'm going to go backwards for a second. If you notice at these, I got a 2 and a 6, no perfect squares. 3 and an 8, no perfect squares. 6 and a 3, no perfect squares. But 4 is, but 12 isn't. So if I see both the first and the last are, okay, then I'm just going to test it. And then see if I can save myself some time. Okay, take a look at, or write this one down here. Factor 36x squared minus 12x plus 1. All right, is your first term perfect square, 36? Yep. Last term's a 1, right? Don't forget that's a perfect square. So right now watch your signs. You got a minus here in the middle. Now this will only work if that last term is a plus. If it's a minus sign, then you have 1 plus and 1 minus to throw things off. All right, what are we going to get? Madison Lissy, what do you think for this one?
6x minus 1.
Okay.
6x minus 1, yeah.
6x minus 1 times 6x minus 1. Yeah, and even for that last one, I probably should have written it as 2x plus 5 quantity squared. So if you got a perfect square trinomial, you're going to end up with a quantity squared as your answer. Okay, for that. And had to test that one there. Okay, now let's throw that other variable in there. We have one in the homework. You got to be able to handle them as well for that. Tony, Stevick, first term of perfect square?
Yep.
Last term of perfect square?
Yep.
So what should I try?
4x minus 3y.
Okay. And?
4x minus 3y.
Yep, just want to make sure you use the same thing twice. Yes, so just make that a y, and then you can make that 4x minus 3y quantity squared. Okay, for that one. All right, so that's trinomial. We also have, x squared minus 16, which is perfect squares. What about x cubed minus 8? Is that a perfect square? No. Is it factorable? Yes, because what is it? It's cubes. We got to do those. We got to know sum and difference of cubes. Okay. There's your two formulas. Now, sum of squares never works. Sum of cubes does. You're going to need to know these equations. Okay? You're going to need to know these. So if you have a cubed minus b cubed, first two is a minus b. And then you got a squared plus ab plus b squared. And then a cubed plus b cubed. All right, there's a little acronym to help you remember the signs. Does anybody remember it? So, what's the S stand for, Josh? Same. So S-O-A-P. If this is a cubed minus b cubed, you're gonna have a minus there. If it's plus, you're gonna have a plus. So same. Good. Opposite. Oh, that's an I there. If it's a minus, then it's a plus. If it's a plus, it's a minus. And the last is always positive. Okay, always positive. Same sign as the original. Opposite, just gonna flip it, and then the last sign is always positive. Let's take a look at a case here. X cubed plus 27. Now it's a plus, so I'm gonna have, it's gonna be a plus b times a squared minus ab plus b squared. You just need to identify what your a and b are. X cubed is fine, but 27 I'm gonna rewrite as 3 to the third power. So that means my a value is x, my b value is 3. Wherever there's an a, I put the x. Wherever there's a b, I put the 3. But you do want to simplify as well. So a plus b is going to be x plus 3. A squared is just x squared. All right, you're going to multiply those together. X times 3, don't write x3, please. Okay, make that 3x. So it's going to be minus 3x plus 3 squared, make it 9. All right, what do those have to multiply back to give me? You multiply those together. It's got to give me the original answer. Okay, you're going to get x cubed plus 27, or the original problem. All right, this trinomial, it looks like it should factor. Does it? Okay, it will always be prime if you did the right work. And here's, you can double check it. What multiplies to get 9 and adds to get negative 3? Nothing. I mean, you can test it, but it should always work. Okay, for that. All right, let's take a look at this second one here. 64y cubed minus 1. That looks close to a difference of squares. 8 times 8 is 64, and 1 times 1 is 1, but the y cube throws it off. So it is going to be a cube. What cube gives you 64y to the third power? 4y. And then you can just think of this as 1 to the third power. So everywhere there's an a, you're going to put 4y. Everywhere there's a b, you're going to put a 1. Now for this, let's see here. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. And so that's going to be 64y cubed minus 1. All right, so that's 4y minus 1. This next one is where if you make a mistake, you're going to make it. What goes where a squared is? What will be at that spot? What is it? 16y squared. Okay, now I'm not going to write it this way all the time, but here's what's going on. Whatever your a value is, you are squaring that whole thing. So it's really 4y quantity squared plus, what's a? 4y times 1 plus b, which is 1 squared. Now, 9 times out of 10, you're just going to do it and write it out. Fine, absolutely fine. But don't make that mistake. Make sure that you, not foil it, but you square the 4 as well. 16y squared plus 4y plus 1. Okay? All right, this last one, do on your own, has a little bit of meat to it. Throw some variables in there. Okay, if you think you're good, just roll with it. If you're a little bit unsure, I'll get you started here in a minute. Now, when you're looking at this here, this is 2x to the third power, and then this will be 5y squared to the third power. You gotta make that 5y squared. So a, everywhere there's the a, you put 2x, 5y squared goes in the second spot. So it's gonna be 2x plus 5y squared. All right, square that. 4x squared minus, multiply those two together. You have to multiply those constants. Don't just leave them like that. So it's going to be what, 10xy squared, and then plus at the very end 5y squared squared. 5 times 5 is 25. Y to the fourth power. Okay. Final answer: 2x plus 5y squared, 4x squared minus 10xy squared plus 25y to the fourth. We good with that? All right, now just a couple little special scenarios we need to watch out for. All right, so go ahead and factor that, or take a look at that one. Factor 2x squared plus 7x minus 8. If you're going grouping method, you're going to say, I want to multiply 2 times negative 8, which is negative 16. I want two numbers that multiply to get negative 16. and at the same time add to get 7. What are those two numbers? Tyler? Nothing. Doesn't work. So what does that mean? Can't factor. You cannot factor that. So you kind of gotten thrown into the idea that everything factors. So you can, and when it doesn't factor, a lot of times you can put prime. It's like a prime number. Prime number doesn't factor into two composites, or you can write does not factor. Now here's the problem. Once we do one of these, every time you get stuck, you just put doesn't factor and then move to the next one. All right. So it's not always the case. Not always the case, but it comes up. Now that's the good thing about the grouping method is that once you get to that step, it doesn't work, then you're done. Okay, then you are done. You don't always have to have x squared. You can have, there's a multitude of different exponents you can have. So we'll just take a look at 2x to the 4th minus 9x squared plus 4. Okay. Now I'm still going to do guess and check with this one. It doesn't affect it. This affects the first term there. So 2x squared, and then the other one has to be x squared. Okay? Because basically it has to be what that middle term is. Okay, normally it's an x, and that makes sense because x squared times x squared gives you x to the 4th. All right, think what other value you're going to get there. Okay, you're just going to do like normal. Those last two have to multiply to get 4. And it's either got to be 2 and 2 or 4 and 1. It cannot be 2 and 2. Why not? Because that means one of the 2's has to be with the 2x squared. You're going to have a GCF. Can't be that. I can't put a 4 here and a 1 here. So it's got to be minus 1, minus 4, right? Does that work? Now I'm not done. Still got to do what? You got to double check and see if anything will factor again. 2x squared minus 1 will not, but x squared minus 4 is a difference of squares, and it'll factor into x minus 2, x plus 2. Okay? So always double check in there. All right, this last one is a unique one. I guess unique is the right word. Once you get figured out, it's not hard, but it's unique in terms of here. All right, I'm going to do something. Don't write this down. Just pay attention. All right, what's your first instinct? First instinct. Go.
Grouping.
Grouping. Okay, that's my first instinct. So I got x squared minus 9a squared. Don't write this down. Plus 6x plus 9. All right, what are you going to do when you group? They don't have a GCF, but actually the first one does factor into what? Difference of squares, x minus 3a times x plus 3a. And this one has a common 3. Okay, now, that's somewhat factored. I mean, I factored individual. Can I do anything else? Stop. Can you consider that to be factored? No, it is not factored because it's not a product. Because we are adding. We are adding this term plus this term. So that is not factored. So it's a good try. Now, a lot of times you're going to say, oh, I'm done. It doesn't factor. That's not the case. These can be rearranged and it will factor at some point. Okay, you usually don't get it the first time until we show you what to do. I'm going to rearrange, and I'm going to put the x's together with that 9. I'm going to make this x squared plus 6x plus 9 minus 9a squared. And now here, factoring like normal grouping still won't give us what we want. It'll factor something, but it won't factor all the way. You got to be a little creative here. Anybody see what we can do? Okay. I'm going to group the first 3 terms. Okay? I'm going to create a difference of squares. What does x squared plus 6x plus 9 factor into? X plus 3 times x plus 3. So it factors into x plus 3 quantity squared minus 9a squared. And you can think of 9a squared as 3a quantity squared. So here's what you got. You got a squared minus b squared. You got a difference of squares, which factors into a minus b times a plus b. All right, how do you think you write the answer? We haven't had anything like this. We know the idea. All right, how do I write that final answer? What do you think? Okay.
Would it be x plus 3 minus 3a quantity squared?
No, close. Close. You're missing something because it's a difference of squares. One of them is going to be minus and the other one's going to be plus. So you're going to do x plus 3. This is like your a minus 3a. Now that all has to be in parentheses. And then times x plus 3 plus 3a. Now you can look and I don't know if simplify is the right word, but I just started with those x plus 3 in parentheses. I can drop those parentheses. There's really nothing I can combine like terms wise, but you'll probably see it just written like this, x plus 3 minus 3a, and then x plus 3 plus 3a. Okay, you'll just see that. Is that factored? Yeah, it's a multiplication problem. This is one you're normally not going to recognize, without having seen it at least once. So you got to take a look. All right, well, grouping doesn't work. Can I rearrange terms and can I do a difference of squares? So you got to come up with some creative ideas on that one. All right, page 48. This is going to be your assignment. I'm going to try and grade this one. Which means I'll probably pick 4 or 5 problems, and actually, you'll be marked for them, and then so in this one, maybe an 8 out of 10, or we'll see. Depends on how bad you miss it. If you are CCP, go ahead and and you haven't done the orientation, I'd pull your computer out, and I'll give you that site. I will freeze that screen over there. So the homework assignment will still be up there. And I am going to stop the screencastify.